In the past, we have learned about direct variation. You learned about it in Algebra 1, and I believe we've talked about it at some point this school year. Direct variation is when, excuse me, direct variation is when y varies directly with x. So the phrase is y varies directly with x, or y varies directly as x. And the equation that we typically use is y equals k times x. K is the constant of variation, and k is a constant number. So k is kind of like the slope. If you have, so I'm going to write in here, to check a table of values, do y divided by x equals k. So if I give you a table of xy, an xy table, and say, does this table represent direct variation? You would take the y values divided by the x values and see if you get that same constant number every time. And all I did was take this equation y equals kx and divided both sides by x to get k by itself. So that's just rearranging the equation. With direct variation, x gets bigger as y gets bigger. Inverse variation is what we have not yet learned. Inverse variation, y varies inversely with x, or y varies inversely as x. And the typical equation that is used is y equals k divided by x. Think of this as like x is inverted to the bottom of that fraction. With inverse variation, x gets bigger as y gets smaller. If I give you a table of values and say, does this table represent inverse variation? If I want to get k by itself, what would you do with this x? Multiply it on both sides. So if you check x times y, and you get the same constant number every time, then it is inverse variation. So numbers 1 through 8, we are going to check to see if these are direct variation, inverse variation, or neither. Let's start with equations. Basically, you want to look at, does this equation look like y equals kx or y equals k divided by x? You may need to rearrange the equation to figure it out. So xy equals 4.8. I would divide both sides by x to get y by itself. Y equals 4.8 divided by x. Does that look more like direct variation or more like inverse variation? Inverse. This one is inverse. Okay, number 2. The problem with number 2 is that x is by itself instead of y being by itself. We want to get y by itself so we can compare it to these two equations. So let's multiply both sides by 1.5. That will give us 1.5 times x equals y. Does that look like y equals kx? Or does that look like y equals k divided by x? So this is an example of direct variation. Take a look at number 3. What do you think about number 3? Do either of our equations say anything about a plus sign? No, they do not. So, do you think it's direct or inverse? No, it is neither. Okay, number 4 is a little tricky. But think about 9 over 3. What is 9 divided by 3? 3. So, the x is still going to be on the bottom of this fraction. But 9 divided by 3 is 3 with the x on the bottom. What does that look like? Inverse. Next, 3y equals 4x. We want y by itself, so we would divide both sides by 3. This one's a little bit tricky because there's a fraction involved. But really, 4 divided by 3 is the fraction 4/3. So this is y equals 4/3 times x. Is the x on the bottom? No, so it can't be inverse because the x is not on the bottom. It must be direct. Okay, with the tables, I'm going to go back up to the top of the screen. Take a look at what I have highlighted. When you look at those tables, if your x values are getting bigger and your y values are also getting bigger, it's probably direct variation. Check y divided by x to see if it gives you a constant number. If, as the x values are getting bigger, the y values are getting smaller, then it looks like inverse, so check x times y to see if you get a constant value. So for each table, we're not just going to guess, we're going to make an educated guess and then check ourselves. So number 6, as these x values are getting larger, 3, 6, 10, 12, what are the y values doing? They're getting smaller. So this might be inverse. I'm going to write check inverse. And if you look back up above, to check inverse, we are going to do our x values times our y values and see if that gives us a constant number. The reason that we're doing x times y, if you take this inverse variation equation and get k on a side by itself, you would have to multiply x on both sides. So when you do x times y, you should get that constant number k. So let's check it. What is 3 times 1? 3. What is 6 times 0.5? What is 10 times 0.3? What is 12 times 0.25? Do we have a constant number when we take x times y? Yes, that means this is inverse variation. Okay, on number 7. The first thing that I'd like you to look at, what are the y values doing as the x values are getting bigger? The last line of this table is a little bit confusing because it's out of order, but look at the x values, 3, 8, 11. As 3, 8, and 11 increase, 12, 32, 44 are also increasing. So this looks like they are both increasing. We are going to check to see if this is direct variation. Now look up at the top of your page. If we're checking for direct variation, what do we have to do? Y divided by x. So let's check our y value divided by our x value. 12 divided by 3 is 32 divided by 8, 44 divided by 11. And now this weird last term, 2 divided by 0.5, is 4. So yes, this is direct variation. I'd like you to try number 8 on your own. As x is increasing, our x values are getting bigger, our y values are getting smaller. So this looks like it might be inverse variation. If I can find my page back. And to check inverse variation, we do x times y. We get 6, 10, 12, 10. Is that a constant number? No. So it's not direct, it's not inverse. It's something else. Okay, now, numbers 9 and 10. Numbers 9 and 10 are the easiest problems you are going to do in Algebra 2. However, they are the most commonly missed problems on the test. I think they're actually too easy, and so you all try to do like too much for it. And when we did direct variation, several of you missed these problems on the test. So I'm going to be very, very clear about what this question is asking for and what you need to write in order to have answered the problem. It says, find the constant of variation. Then it says, write the equation of inverse variation. Then it says, find y when x equals 2. So this is a part A, part B, part C problem. We have to do all 3 parts of this problem. So part A, find the constant of variation. It says y varies inversely as x. Y varies inversely as x means it's inverse variation, and the generic equation for inverse variation is y equals k divided by x. The constant of variation is k. You're trying to figure out what is k. So they're telling you y is 9 when x is 4. So I'm going to put 9 in place of my y and 4 in place of my x. Can we now figure out what k is? Yes, we can multiply 4 on both sides and we figure out that k is 36. That's the first thing we were supposed to find. Find the constant of variation. The constant of variation is 36. Next it says, write the equation of inverse variation. They want you to go back to this y equals kx, k over x, and put the k value that we just figured out into that equation. So make sure you write y equals 36 over x. If you do not have that equation written, you are going to get the problem wrong because the directions say write the equation of inverse variation. So you have to make sure you get that equation written. Part C, find y when x equals 2. So now use your equation and plug 2 in place of x. What is 36 divided by 2? So our final answer is y equals 18. I would like you to do those 3 steps on number 10. Go. It says x and y vary inversely. If you see inversely, that means you're using the inverse variation equation, y equals k over x. Plug 7.5 in place of your y, plug 4 in place of your x, and then solve the equation for k. To figure out what k is, you would multiply both sides by 4 to get k by itself. K is 30. Next step, it says write the equation of inverse variation. So rewrite that equation, but now you know what k is. So y equals 30 divided by x. Step C, use your equation to figure out what y is when x is 2. So you're plugging 2 in there. Y equals 15. If you're watching the video, you should pause right now and get this written down on your notes. Once you have all of this written down on your notes, then play the video again.